The James Webb Space Telescope has captured something that could change the way we think about the universe. Shining from a point just over 4 light-years away, mysterious lights, resembling those of a city, have been detected coming from Proxima Centauri b, the closest known exoplanet to Earth. This unexpected glow has sparked renewed excitement about the possibility of intelligent life beyond our solar system. Scientists are now closely studying these bright flashes, which appeared far too structured and consistent to be natural phenomena. Could we be witnessing evidence of an alien civilization? For decades, both scientists and the general public have speculated about life on other planets. The idea has long captured human imagination, and any sign, however faint, has been met with anticipation. Now, this discovery may mark a pivotal moment. The powerful instruments aboard the James Webb Space Telescope picked up lights from Proxima Centauri b that resembled artificial illumination, like the glow from a populated area on Earth. This has led researchers to consider a fascinating possibility, that intelligent beings might be living on this distant world and constructing their own versions of cities. The nature of the light is what makes this discovery so compelling. Proxima Centauri b doesn't behave like most rocky planets. Typically, planets absorb sunlight and re-emit energy as infrared radiation. However, this particular exoplanet appears to be reflecting or emitting light in ways that suggest an artificial source. This unusual behavior, combined with its proximity to its parent star, has drawn significant interest from scientists. Astronomer David Kipping from Columbia University described the planet's environment as unusually complex, suggesting that its interaction with Proxima Centauri is unlike any planetary system we've observed. The James Webb Space Telescope played a critical role in detecting this anomaly. Its unmatched sensitivity to infrared light allows it to capture faint details invisible to other telescopes. This capability enabled it to observe what appeared to be nighttime glimmers on the dark side of Proxima b, light that some speculate could originate from artificial sources. These observations raise a host of questions. How long have these lights been shining? Are they natural phenomena we simply don't yet understand, or is it possible they were created by intelligent beings? Unlike most ground-based telescopes, which struggle with the immense darkness of space and atmospheric interference, the James Webb Telescope excels in isolating even the most subtle light signatures. This is particularly important when studying Proxima Centauri b, as any artificial illumination would likely fall within a very narrow frequency band, narrower than the broad spectrum emitted by stars. If the telescope continues to detect these distinct bands consistently, it could point toward technological activity rather than natural reflections. Proxima Centauri b is an especially interesting candidate for this kind of exploration. Its orbit around its host star, Proxima Centauri, creates a cycle of day and night similar to Earth's, though much more intense. Because of its close proximity to its star and the absence of oceans or a thick atmosphere, the planet likely experiences dramatic temperature fluctuations. During the day, the surface may heat up significantly, while the night side could plunge into extreme cold. If the planet lacks an atmosphere, these extremes would be even more pronounced, providing important insights into its habitability. The thermal changes on Proxima b offer clues to its atmospheric composition, and the James Webb Telescope's infrared imaging can capture those shifts in detail. By measuring how heat is distributed across the planet's surface, researchers can infer the presence or absence of an atmosphere. Moreover, the telescope's orbital alignment allows scientists to gather data on Proxima b's cycles every 11.2 Earth days, giving them repeated opportunities to confirm and refine their findings. If an atmosphere is confirmed, the next phase will involve identifying its chemical components. Scientists will examine how light from the parent star passes through the planet's atmosphere, looking for key indicators like oxygen, water vapor, and methane. These molecules are often associated with biological processes on Earth, and their presence on another planet would suggest the potential for life. Though the James Webb Space Telescope wasn't originally designed solely for identifying alien life, it's proving to be an invaluable tool for this kind of investigation. Its ability to detect subtle variations in the levels of gases like carbon dioxide, methane, and water vapor make it ideal for studying distant planetary atmospheres in fine detail. This discovery is still in its early stages, and scientists remain cautious. But with each observation, we inch closer to answering one of the most profound questions of our time. Are we alone in the universe? The lights on Proxima Centauri b might be the first real clue that we are not. While the James Webb Space Telescope has its limits, particularly in detecting free oxygen, a key indicator of life, it can still identify other crucial atmospheric elements like ozone. Ozone serves as an important marker of a stable and potentially life-supporting atmosphere. As scientists continue to analyze data from this remarkable telescope, the search for life on distant worlds grows more focused. Every new discovery adds a piece to the puzzle, bringing us closer to answering the age-old question of whether we are truly alone in the universe. However, it's important to recognize that the James Webb Telescope is only capable of observing a small number of nearby exoplanets. To expand this effort, astronomers are eagerly anticipating the arrival of more powerful, Earth-based instruments. One of the most promising is the Extremely Large Telescope, or ELT, which is scheduled to begin operations in 2028. The ELT will offer an even deeper glimpse into the atmospheric composition of distant worlds, allowing scientists to collect high-resolution data and potentially confirm the presence of life-sustaining environments. Until then, the James Webb Telescope continues to be a vital instrument in the study of exoplanets. It offers capabilities that, while not perfect, are still far beyond anything previously available. And even with its limitations, the telescope is helping redefine our understanding of what lies beyond the boundaries of our solar system. In parallel, scientists are working on designs for future space telescopes that can perform even more specialized tasks. A key focus of these future projects is developing technologies that can reduce the overwhelming brightness of starlight, allowing astronomers to better observe the faint reflections from surrounding planets. Think of it like trying to spot a tiny firefly next to a spotlight. That's how much brighter a star is compared to any of its planets. Blocking that star's light is essential for studying the planets around it. New tools are being developed to tackle this very issue. One of the most promising innovations is the coronagraph, a device placed inside the telescope to block out the central light from a star. By reducing the glare, it makes it easier to detect the much fainter light reflected by nearby planets, enabling more precise studies of their atmospheres. Another groundbreaking concept is the starshade. This massive, flower-shaped spacecraft would fly in formation with a telescope, staying tens of thousands of kilometers away. Its job is to block the starlight before it even reaches the telescope's lens, allowing only the light from the planets to be captured. This method could be especially useful in examining planets located in the so-called habitable zone, the region around a star where temperatures are just right for liquid water to exist. Both the coronagraph and the starshade require incredible precision to function effectively. The alignment of the starshade, for instance, must be accurate to within a fraction of a millimeter, even across vast distances in space. These systems must also contend with the usual challenges of space exploration: limited energy, tight constraints on size and weight, and the harsh conditions of deep space. But despite these hurdles, the potential payoff is immense. If we succeed, we could finally detect chemical signatures of life, such as specific ratios of oxygen, methane, and water vapor, in the atmospheres of distant exoplanets. Researchers are also exploring the possibility of capturing detailed images of these far-off worlds. Future telescopes may feature advanced adaptive optics, which would compensate for distortions caused by Earth's atmosphere or minor shifts in the telescope's alignment. This would result in clearer, sharper views of distant planets. When combined with starlight blocking technologies, this could allow scientists to not only identify exoplanets but also study their surfaces, climates, and potentially even seasonal changes. The advancement of these next-generation observatories marks a major leap in humanity's effort to understand our place in the cosmos. By pushing the boundaries of what our instruments can see, we inch ever closer to discovering life beyond Earth. If life does exist on some distant planet, These upcoming technologies may be what finally allow us to see the first hints of it. The question of whether we are alone may not remain unanswered for much longer.